Hi again, I'm Dave from DPS Instrument Europe, and this is our companion to Portable GC. It goes with you anywhere. In the episode today, I'm going to be discussing packaging contaminants. Excuse me 1 second. Refreshing. But it's empty, so what do? We recycle it. How does that happen? Well, they take the bottle back to the manufacturer, grind it up, clean it, make it back into small resin pellets that they can injection mold back into this preform. This preform then gets shipped off to the bottling company and it gets blown up into this shape and refilled again. All this can happen many times. Problems, however, can arise when you're looking at recycled material that this bottle could have had other stuff in it, other chemicals like benzene or toluene, or if it was a lemon lime drink, it could have been limonene. And these can contaminate this. And when it gets blown up and refilled, it off-gases into the new solution, water or Coke or whatever it is, and it's contaminated. This is where the companion comes in. Let's put it on the bench and take a look. Now that we have this unique packaging configuration up on the bench, let's take a look at the parts. Power entry module, color touchscreen of course, computer interface, one FID detector, the column oven, 30-meter capillary column. This is our heater module for the headspace vial, the switching valve and oven, the trap concentrator module because we're looking at part per billion levels, our clever little vial cleaner, and the input gas connection. Once again, this is the packaging configuration. Okay, let's take a quick overview summary of how this works. First, you weigh your resin pellets into the headspace vial and cap it. Put it in the vial heater to preheat and drive all of those compounds off the resin into the headspace. Once that is done, simply insert the transfer probes and start the run. What happens is gas will flow through the headspace vial and lift all those compounds out and concentrate them on the adsorbent trap. At the proper time, the trap will heat, the valve will rotate, and transfer those compounds onto the analytical column for separation and detection. That's really all there is to it. Preheat the vial, insert the probes, push the start button. You're ready to go. Okay, let's explain a little bit about our clever little vial cleaner. Well, if your companion is out in the production facility where you have forklifts driving around or normal trucks, the air in the room can be pretty contaminated. And when you weigh the pellets, you are actually filling this vial with that contaminated room air. And at part per billion levels, you're going to see those peaks. So we've created this vial cleaner. So once you weigh the pellets into the vial and seal it, simply put it on the cleaner and hit the start button. After about 30 seconds, the air inside has been completely exchanged with clean air, and now you're ready for your normal analysis. Once again, the vial cleaner option. We know that this configuration is great for resin samples, but what else can you do with it? Oh, there's so many things. In a normal headspace vial, you could put fabric pieces like this, or tire pieces, or paint chips, or plant material, or even cornflakes. All of these could go in a headspace vial and heat it up to drive those compounds off those products and onto the absorbent trap for part per billion analysis in all of these other configurations and sample types. Once again, this configuration is incredibly versatile. Once the GC is booted up, the resin method comes up automatically. It's preloaded with all of the parameters necessary to completely run this method automatically. And let's look at some of the things that we have inside. Using our quick navigation bar, if you press on the oven page, has everything to do with the column oven. The oven temperature, the second is the vial heater, which is going to 200 to get those compounds off the resin into the headspace. The trap is going to heat up to 275, and we're keeping our transfer valve at 125. If we look at our temperature program for the column, it starts and ends at the same temperature. This is an isothermal run. However, on the pressure page, we can see that we actually have a pressure program. We're using the pressure to drive those compounds off the column at the end of the run. On the timeline, we can see the timed events of turning on the gas to get the compounds out of the headspace vial onto the trap, and then we preheat the trap, and then we rotate the valve to desorb those compounds onto the analytical column. And then at the end, we turn the purge gas back on to clean up everything in between. And this is all in a tabular form, but if you want to look at it graphically, go to the run page. The top is the temperature program, here is the pressure program, and here are those timed events I was talking about. So once you put your resin sample in and your probes inside of it, all you have to do is press the start button to start the run. The progress bar immediately starts, and the first thing you're going to see is the purge gas comes on to transfer those compounds out of the headspace vial onto the trap. So, let's get going. You can hear the valve switch on, and immediately the chromatogram is pulled up. But we can toggle back and forth and look at the oven, or look at the FID detector parameters, or look at the pressure program, or look at the run page, or go back and look at the chromatogram at any time that we want. The software is very easy and very convenient. And there you have it, the Packaging Contaminants GC Analyzer. Starting with a flash that needs to be recycled through the resin pellets, all the way through the preform. Every step of the process can be validated using the DPS Packaging Contaminants. And not only that, you can put other stuff in the vial. Paint chips, or pieces of tire, or fabric, or forensics, or cornflakes. And with a convenient vial cleaner, everything is included and automated for this analysis. Once again, I'm Dave from DPS Instruments Europe. This is our Packaging Contaminants GC Analyzer, and I thank you for your time.